In this lesson, I'm going to teach you how to solve a trig equation with a number in front of theta. That means there's a period change, and it's just as simple as solving the ones we've done before. We're going to start off the exact same way. We're going to get the trig function by itself. So I'm going to divide both sides by 4. And I get sine 3 theta equals 1/2. Now notice that this 3 here did not change to 3/4. You can't divide into a function. This 4 can't go into that 3 because the 3's inside the sign here. So it's only going to divide into the number outside the sign. So then next, I'm going to do just what we did before. I'm going to go to my unit circle and say where is sign positive, because there's no negative in front of here. There's a positive, so I'm looking where it's positive. And that happens in the first and the second quadrant. So by doing inverse sine, I get 3 theta. And the angle that gives me a sine of 1/2 is pi over 6 in the first quadrant and 5 pi over 6 in the second quadrant. Now before, on our simple equations, we'd be done. However, we have this pesky 3 hanging out there. So what does that mean? Graphically, that means that when we graph our sine, we get 3 sines in one normal period. Algebraically, what this means is go around the unit circle 3 times. So to go around the unit circle, you have to add 2 pi. That means we're going to add 2 pi to these answers. Let me make us some room. What I like to do then, since I'm going to be adding 2 pi to these numbers and their fractions, is I like to off to the side write a common denominator. So if I'm adding 2 pi to pi over 6's, that's going to be the same as adding 12 pi over 6. So all I'm doing here is converting it to a common denominator, so I don't have to keep thinking, what is 2 pi as pi over 6? I can just glance over and not have to really think about it. So let me just erase these 2 pi's so it's a little neater. Alright, I'm going to add 2 pi to the pi over 6 and I get 13 pi over 6. Then I add 2 pi to the 5 pi over 6 and I get 17 pi over 6. So this is my second time around the unit circle. This was my first time. I have a 3, which means I have to go one more time. So again, I'm going to add 2 pi. So I add 2 pi to the 13 pi over 6 and I get 25 pi over 6. And then I add 2 pi to the 17 pi over 6 and get 29 pi over 6. And that's my third time around. So notice right now I have 6 answers here, and before I used to have 2. So if you want to know how many answers am I going to have, it's usually this number times 2. So in this case, 3 times 2 is 6. If there was a 5 here, you'd have 10 answers. If there was a 10, you'd have 20 answers, and so on. So we're almost done. We have one last thing to take care of. Just like any normal equation, you want the theta or x by itself, so I need to get rid of this 3. I divide by 3. That means I'm going to divide every single number here by 3. And let's go off to the side. So if I take pi over 6 and divide it by 3, that's the same as taking pi over 6 and timesing it by 1/3. So you're essentially multiplying the denominator by 3. You always want to check to see if you can reduce as you multiply. But so the lazy way of doing this is, once you check to see if you can reduce, is you could go and change all of these denominators to 18. Just to make it a little neater, I will write them over here though. Theta equals pi over 18 So pi over 6 divided by 3. And then we got 5 pi over 18. And then 13 pi over 18. Alright, we are done with this problem now. So we have 6 answers. They're all over 18. Do a last double check that you can't reduce any of them. And then you also want to do a quick check that this is still under 2 pi. So 29 divided by 18 is less than 2. You can double check that on your calculator if you don't believe me. So it's less than 2. So we haven't gone over our domain here. And so we are done with this problem. Our second example is very similar to the first. We have a 2x instead of a 3x, but I'm going to start off the same way. So I'm going to divide everything by the number outside the trig function, which is a 2 in this case. And I get tan 2x equals negative 1. Now this is where it's very tempting to want to reduce these 2's here, but remember this 2 is in the trig function, so you can't reduce it. It has to stay the 2x. Now at this point my trig function's by itself, so I go over to my unit circle and I say, where is tangent negative? It is negative in the second and fourth quadrant. So I do inverse trig and I say 2x equals, now what angle gives me a negative 1? This is the one people can get stuck up on sometimes because it's a tangent. Remember, tangent is y over x. So to get a 1, y and x have to be the same, and that occurs when you have rad 2 over 2, rad 2 over 2, which is at your 45 degrees or your pi over 4s. So in the second quadrant, a pi over 4 reference angle is a 3 pi over 4 angle. And in the fourth quadrant, a pi over 4 angle is 7 pi over 4. So this is my first time around the unit circle. I have a 2, which means I need to go around one more time. So I have to add 2 pi, and I'll go off to the side like before and get my common denominator. So 2 pi in force would be 8 pi over 4. I'm going to add that to both angles, so 3 pi over 4 plus 8 pi over 4 is 11 pi over 4. And 7 pi over 4 plus 8 pi over 4 is 15 pi over 4. So that is my second time around the unit circle. I only have to go around 2 times because there's a 2. So my last step here is I have to get rid of this 2 in front of the x. I'm going to divide everything by 2. Which is the same as multiplying these denominators by 2. So I can be lazy if I want to and change all these denominators to 8s. So now you want to check and make sure you can't reduce any of these fractions here. So 3/8, 7/8, 11/8, nothing can be reduced. So x equals 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8. And remember, we're going to have 2 times whatever this number was answers. So 2 times 2, we have 4 answers. This is our final solution. It's always good to double check this last number here and make sure that isn't over 2 pi. So 15 divided by 8 is a little less than 2. That means we are in the domain. We're less than 2 pi, so these are all valid answers. And our final example. We're going to start it off like we started off all the other ones. We need to isolate the trig function, so get cosine by itself. In this case, it's 2 steps. I've got to subtract 1 from both sides. So I get rad 2 cosine 1/2 x equals -1, then divide by rad 2, and I get cosine 1/2 x equals -1 over rad 2. Have to rationalize that, so hopefully this would look familiar to you as a unit circle angle, and it simplifies to rad 2 over 2. Now that should look like a unit circle ratio, and I go back to my unit circle and I look, cosine's negative because I have a negative in front of that rad 2 over 2, and cosine is negative in my second and third quadrants. And again, this is a pi over 4 reference angle, so this angle would be 3 pi over 4, and this angle would be 5 pi over 4. Hopefully you're thinking to yourself, but what does that 1/2 have to do with anything? This number before had been telling us how many times to go around the unit circle, and it's still doing that. So really, we only want to go around the unit circle halfway. So we don't even want this lower portion of the unit circle, which means this 5 pi over 4 isn't really part of our answer. So at this point, you could cross that answer out, or if you weren't sure, because especially if this 1/2 or something like a 1/3 or 1/5, it can be harder to tell what portion of the unit circle that is. It's fine to keep going at this point and solve for x. So we're going to multiply both sides by 2. So I multiply everything by 2 over here, and I get x equals 3 pi over 2 with reducing, and 5 pi over 2. And if you remember, I said always check your biggest angle. Make sure it's under 2 pi. So 5 divided by 2 is actually 2.5 pi. So this angle shows up as being outside our domain up here, which again tells us that this is not part of our answer. So our only answer is x equals 3 pi over 2. So you can accomplish the final answer either way, by realizing we're only going halfway around the unit circle, like I did up here, or you can go all the way to the end and check your answers and make sure they fall into this domain of 0 to 2 pi, and if they are outside the domain, they are not part of your answer. So I hope this was helpful, and good luck on your assignment.